So let's go over the homework, chapter 2 homework. People said they wanted numbers 9, 2b, 3, 4, etc. 11. Those are ones I've got so far. Can I make this? It's not working. So we'll start with numbers 2, 3, and 4. Let's start with this first section, and then go on to the next stuff. So in the first section, we are talking about finding the average rate of change for each function. So number 2, 2b, and 3 and 4, some of these other ones. Oh, so 3, 4 with the e and the ln, right? Those were maybe a little confusing. E and ln. All right, so let's start with 2 and do 2b. Square root of 4x plus 1 from 10 to 12. So 2b, you know what, let me see if I can make this work. Hold on, everybody. I don't know why my pen doesn't want to register. You're going to be working now? Okay, fine. 2b, square root of 4x, what was it, 4x plus 1 from 10 to 12. 4x plus 1 from 10 to 12. And we want to find the average rate of change there. So for this, the average rate of change, the formula we have is a slope rate of change. It's f of b minus f of a over b minus a. Here's a, here's b, and you just plug it in. F means plug in the b, plug in the a, right? So I'm plugging in the 12. I just plug in the 12 to the equation here. So square root of, square root of 4 times 12 plus 1. And then the a, plug in the a, minus square root of 4 times 10 plus 1, all over the distance between those 2 points, 12 minus 10. So you're finding a slope. You need to all be very, very good at just doing this automatically. Find the slope just means plug in the values, plug in the points. The confusion may be the square roots, and we get like values that are not exact. Let's find out. 4 times 12 is what? 48 plus 1 is 49. That's nice. 4 times 10 is 40 plus 1 is 41. A little less nice. 12 minus 10 is 2. So my average rate of change between those 2 points, that's going to be a 7. The square root of 49 is 7. Minus square root of 41. I don't know. There's no exact number. This is not precise, right? So we would use a calculator, grab ourselves a calculator, and find it out. Calculator. And so if I plug this in, SQRT of 41, I'm going to get about 6.4. Seems fine. Plug it into a calculator, get an approximate answer. 6.4 is great. Over 2, that's going to be, what is that? 7 minus 6.4 is 0.6, right? 0.6. 0.6 over 2 is about 0.3. And that's fine. And that is, again, that's the average rate of change. That's the average slope of this equation, f of x, from 10 to 12. So if we look at the graph, this graph is going to look something like this. And if you look from 10 to 12, the average rate of change from this number to this number, the slope of that line is going to be about 0.3, which is, you could say 1/3. You can have decimals for it, right? But the slope of this line is about 0.3. If you're finding slopes like approximates are totally okay. Approximate values are totally okay with this. And if you get in a situation where you can't get an exact number, like square root of 41, use a calculator. Use a calculator. Totally fine. Totally fine. Right, so average rate of change. Our formula for the average rate of change, again, you're using this equation here. F of b minus f of a over b minus a. Our average rate of change. Just plug the values in, calculate the slope. All right, questions about that? People okay with that? We're good? We're good. Let's try doing numbers 3 and 4. People had a problem with E and the ln, right? E and ln. Again, these two things are just use a calculator. Use a calculator, plug in the e to the -2, plug in e of 0, plug in ln of 1, plug in ln of 4, plug in the values in the calculator, and get an answer. E, everyone has e in their calculator, and everyone has ln in their calculator. These are just various kinds of graphs, special graphs that get used quite a lot in calculus, in AP Calc. E is simply an exponential equation. If you're looking at E, the graph of e to the x looks something like this. This is e to the x. Graph of ln of x looks like a logarithmic graph. Looks something like this. They each have some special features. E has an asymptote right here, horizontal asymptote at 0. Asymptote. And ln has an asymptote at 0 here. A vertical asymptote. Asymptote. They both grow forever, but these are the basic features of these two equations, E and ln. And so for each one, if you're asked to find a specific value, you're just going to use the calculator. Plug it in, get the calculator answer. ln, plug in the 1 or 4, get a calculator answer. No different than what we just did with square root. If it's asking for a specific number, we'll plug the calculator in, get a specific value. All right. Are people okay with these two things? Should I go over it, 3 and 4, or are we okay? Let me know in the chat. Would you like me to do one, or can we move on? Should I do number 3 or number 4, or are we okay? Yeah, right. It's the same thing. You plug it in, right? A and B. Plug the A, e to the -2, e to the 0. Get your calculators. I think we're all right. Let's look at numbers 9. Again, for 9 and these, I wanted you to just do part A and draw the line. Don't worry about these other parts, right? Just find the slope at this particular value. So this is where we are finding the instantaneous rate of change. This is slope of the curve. We're looking for the slope of the curve, right? And I think a picture, if you want to see a picture of this, it's if you imagine this graph here. Let's just take this graph for example. The average rate of change. Stop it. Oh goodness, what's happening here? There we go. Your average rate of change is going to go like from P to Q1 is going to be something like this, right? It touches, it kind of skirts along from 2 points. This is your average rate of change. Average rate of change. Average rate of change. The instantaneous rate of change would be the slope of the line exactly, the slope of the curve exactly at this point. And so it would just touch there one time. Didn't do a very good job. Touch there one time. Touch the graph in a single spot and be a tangent curve. Tangent to the curve. The slope at that particular value. And I think I need to show you, I want to show you an example today of what this means. But to do this, so let's look at number 9. We have our equation y equals x squared at x equals -2. So we want to find the instantaneous rate of change. This is number 9. Find instantaneous rate of change at x equals -2 for the equation y equals x squared. We're going to do the same thing. Our formula for this is the instantaneous rate of change, I rock, because you all rock, everybody, is the limit as x approaches the number we want of f of x minus f of a over x minus a. This is our formula for instantaneous rate of change. It's like we're doing a slope, but we get the second point, we take the limit as the second point approaches the x value, approaches the particular place we want. So our value of x approaches this -2, and we meet together, and we have a slope that has an infinite, like no rate of change. Like the x values are the same. And so our slope is the slope of a particular tangent line. So let's try this out. Limit as x approaches, in this case, our a value is -2. That's what we're looking for at that location. So that's what we plug in. Not equals. Of f of x minus f of -2 over x minus -2. So we're plugging in our number into the second half, and we're leaving x for later. Oops. We're leaving our x value in place, because this x value we're going to do the limit of. So we need our x value, right? This is our flexible x value. This we plug in our -2. F of x, we just use the equation, x squared minus -2 squared, plug in the number, over x. This is going to be minus is +2. Put that down there. Okay. So this is going to be x squared minus 4 on the top over x plus 2 on the bottom. Right, because -2 squared is a positive 4. -4, -4. So we're using our formula, right? The way we use this formula, again, the way we use this formula is you have your equation, you plug your equation in first, leaving the x by itself. Just use the equation minus the equation with the point plugged in. Equation minus the value. At the bottom it's x minus the value. Equation minus the value, x minus the value. So we get this here, and when we do these, we have to do a little bit of limit manipulation, right? We're solving this limit. X squared minus 4, I can factor x squared minus 4 into x plus 2 and x minus 2 over x plus 2. And here is where we do our limit simplification, or we cancel these two here, and so we say that we want the limit as x approaches -2 of x minus 2, which is going to be -2 minus 2, which is going to be -4. And this is the slope at x equals -2. That value is the slope. Yes. right here, you mean? So this is, what I'm doing is I'm plugging -2 into the function. That's what happens here, right? This -2 gets plugged into the equation. And that is what ends up right here. So you're using the equation twice. You're using the equation one time with just x, one time the whole equation by itself. The second time you're using the equation with the number. So x squared gets used 2 times. X squared gets used 2 times. Right? The formula, the equation, whatever the equation is, gets used 2 times. Once you leave it alone, once you plug it in. Same down here. One time you use the x by itself minus the value. And this is going to get us our slope. Yeah, we're using this equation 2 times. Once by itself, once with the value plugged in. Does that help? Should we try this again? Number 10 maybe? Or which? Number 11? 10, 11? I'll do 10 and 11. Why not? So 10. X squared minus 4x, where x equals 1. Okay. So again, we're going to find the limit of the, we're going to find the slope of the tangent line. So number 10 is y equals x squared, oh shoot, plus 4x? X squared minus 4x at x equals 1. I want to find the slope of the tangent line of this equation at x equals 1. So I do the limit as x approaches 1, we're going, of f of x minus f of 1 over x minus 1. So I use my equation 2 times. One time it's alone, x squared minus 4x, regular, minus, second time, I plug in the 1. I'm going to get 1 squared minus 4 times 1 over x minus 1. One time regular, one time plugged in. And I'm finding the limit, right? So I got to do my manipulation here. I'm going to do some solving, some calculating, right? X squared minus 4x is going to stay the same. Minus, let's see, this is 1 minus 4, that's going to be -3. Minus -3 is plus 3. One squared is 1. -4 times 1 is -4. 1 minus 4 is -3. Minus -3 becomes plus 3 in the equation. Good? And now I have to solve this limit, and I solve by doing some factoring. Now this is going to be some MA factoring, or trinomial factoring, everyone. How do I break apart, right? How do I figure out how to factor this? If it's been a while since you've done some factoring, let me refresh your memory. You take the last number and you think, what 2 numbers multiply together to make 3? What 2 numbers multiply together to make this? And the only choice is 3 times 1. And then you think, how do I make this 3 and the 1 add up together to make -4? If I want to make -4 from 3 plus 1, well, both the 3 and the 1 have to be negative. -3 plus -1 makes -4. -3 times -1 makes +3. So both negative make a -4. Both negative make a +3. So you're looking for what numbers multiply together to make the last one and add together to make the -4. This is the MA factoring, right? Your trinomial factoring. A little refresher of factoring, right? What numbers multiply to make 3, add to make 4. -4. So we have a -3 and a -1 because we wanted -4. So these numbers, -3, -1, become the numbers I have in my parentheses, x minus 3, x minus 1. That's how I factor that apart I find these numbers that work out to be the two parentheses. A little refresher. I know it's been a while, right? We've been doing math up here. You got to bring it sometimes back down to our factoring level. Oh, what do I do that? What is a square root? How do I add numbers together again? I know all that stuff gets lost amidst all the limit business we're doing. But important to know. Remember how to factor. So we factored this apart. -3, -1. I got my two parentheses here. And look at this. Lo and behold, we have a cancellation, as we always will. Always will. So I want the limit as x approaches 1 of x minus 3, which is 1 minus 3, which is -2. And that is the slope of the tangent line at x equals 1. Slope of -2. Okay? It's starting to get a little bit better, starting to feel a little bit more making sense, right? You plug in the equation, you plug in the value, you divide. You're going to do some factoring, you're going to do some simplifying. Whatever rules we talked about for limits, you're going to use those to start to simplify your limits and get an equation you can solve, get a limit you can solve. Let's try 11. This one was a little different. 1 over x minus 1. So our equation for number 11 is 1 over x minus 1. And we want to find the tangent slope at x equals, what was it? X equals 2. Tangent slope at x equals 2. Slope at x equals 2. We do this the exact same way. We want the limit as x approaches 2 of 1 over x minus 1, regular equation first, minus 1 over 2 minus 1 over x minus 2. So this is going to require a little bit more manipulation. 2 minus 1 is 1, so really this is just 1 over 1 over x minus 2. And now, how do we figure out, how do we simplify this business with this fraction and this situation here? How do we do any of this? Does anybody remember what we do to simplify this fraction-y business up here? There were a number of tools we had. For manipulating this. What's like the first kind of step in dealing with this fraction stuff? What do I need to do first? Dealing with this. Yeah, exactly. Thank you. Yes, exactly, Lizette. I want to make these denominators the same so I can combine these two fractions into one. I don't like that they're separate. I need to make them together. When we have fractions, we got to combine them together so we can do some flipping. In this case, I have x minus 1 down here and a 1 over here. So I need to give each one the parts they're missing. So I'm going to give this 1 another x minus 1 piece, because that's what this has. This has x minus 1. I need to give this to the other side. X minus 1 on the bottom, x minus 1 on the top. Right, so I give the x minus 1 to the top and bottom over here. On the bottom here is a 1. Well, I can give this side a 1. It doesn't change the things. It just gives it a 1. But no matter what, I give the bottom part, I give what's missing to each piece. This had x minus 1, I give it over here. This had a 1, I give it over here. Just a quick way to get like terms. Quick way to get like denominators. You take the thing you have over here, give it to the top and bottom on this side. Take the thing over here, give it to the top and bottom on that side. Quick and easy way. So I'm going to have 1 over x minus 1 on the thing here, minus x minus 1 over x minus 1 over x minus 2. When I combine these together, this top part is going to be 1 minus parentheses x minus 1 over x minus 1. It's important to keep this parenthesis here because you're subtracting this entire piece, right? It's a minus this entire piece over x minus 2. Whoops. See what's happening here, everyone? This 1 is here. 1 minus x minus 1. That's the top half. These two combine together, right? The bottom parts they combine into one big fraction. X minus 1. So it's like what I did is combine these two with one big and just keep one of the two on the bottom. And that's minus up there. Right? It's a subtraction, so it's a subtraction on the top. And the subtraction, I now need to distribute the minus sign to both of these pieces, which is going to make it so that I have 1 minus x plus 1 over x minus 1 over x minus 2. Okay, let's keep some simplifying happening. 1 plus 1, this is going to be negative x plus 2 over x minus 1 over x minus 2. And I've got this whole complicated fraction. When we have a complicated fraction, what do we do to flip-a-do this thing? Let me make this a little bit clearer. This is an x plus 2 on the top and an x minus 1 on the bottom over big fraction x minus 2 on the bottom. How do I manipulate this to solve this problem of now I have a single fraction on the top and a thing on the bottom? Someone want to chime in? Tell me how I flip-a-do this. Let's see. Adrian, I'm going to call you. Calling you out. Any ideas? Anguiano. The flippy multiply thing, yeah. Yeah, right, you take this and you make this a fraction, and then you flip-a-do, right? You flip it upside down and multiply it to the top. Exactly. Make the bottom a fraction, flip-a-do, right? So we're going to have, oopsies, wrong color, we're going to have negative x plus 2, and I'm going through this like step by step, but you can do this, if you can like do this quicker for yourself. That's a 1 there, minus 2 like this. So you see I took the bottom part, I flipped it, I get a 1 over x minus 2, I get this negative x plus 2 over x minus 1. What can we do here? Is anything canceling? Well, not quite. This is x minus 2, and this is negative x plus 2. There's a little clue here, though. Like you see, like they're not the same, but they're like opposite, right? I have a negative and a positive and a positive, negative, right? They're opposites of each other. That's like close. And when you get like this, when they're opposite like this and they're pretty close, we have a little way that we can rearrange it. We can flip it. We can make them into the same. I take this top part and I factor out a negative 1. I take this top part, I pull the negative out, and I flip this to be x minus 2. Pull this negative 1 out, and then I get x minus 2 here, and now they're the same. Now they're the same. So if we get this situation where it's like, well, they're almost the same, they're almost identical, except opposites of each other, to fix that, I pull a -1 out and make them into the, and then they turn into the same thing. Pull the -1 out, factor out the -1, and it changes it to be the same things. And now I can cancel the x minus 2, and what are we left with? I have -1 on the top here. This -1, oopsies. This -1 has to stay. -1 on the top here. Over x minus 1. That 1, this whole thing just kind of disappears. The 1 I don't really care about because it's just a 1. 1 times all this stays the same. 1 times -1, still going to be -1, right? So I'm not even going to worry about that 1 on the top. I have -1 over x minus 1, and I'm doing the limit as x approaches 2 of -1 over x minus 1. So that's going to be -1 over 2 minus 1, which is going to be -1 over 1, which is going to be -1. Whew! Wipe the sweat off your brow, everybody. So this manipulation of our fraction limit, that's how we do this, right? We take our fraction limit, we're going to have to do this trick with the combining, right? Finding common denominators, creating a common fraction, flipping the common fractions, and sometimes we'll have to factor out our negative here to make them the same. They'll cancel, and we get the -1 over x minus 1 is our solution. So just like when we did the factoring for the one before, right? Just like how we did for these ones, we have to factor and cancel with squared problems. The fraction problems, you will have to do this stuff. You'll have to do the common denominators, flipping, canceling, and getting your answer. Not a lot of tricks we have, but the ones we have to remember. So factoring for squared ones, fractions, you're going to do the little flippy trick. Okay? So that was number 11. Finding the slope of the curve. Oh, and I wanted you to graph this and find the tangent. So let's graph this 1 over x minus 1 equation. Let's do the graph. Let me show you that. 1 over x minus 1 looks like an asymptote, +1. And looks like this and like this. Yeah, we need to start remembering these names, right? The flippy-doo, the thingy. All right, what is it? We're looking at x equals 2. So here is x equals 2, right? This is a 1 where the asymptote was. So x equals 2 is right there. Slope of this tangent line is -1. It's exactly like, oopsies. Try doing this a little bit better. It would be like this. Let me try better. I want to get it exactly on the tangent. I keep missing. Exactly on the tangent. There we go. That's pretty good. That would be our slope. Slope of -1. All right. Should we try any of these other ones? What's happening here? Free fall object. These are all the same. All of these are exactly like what we just did, except now we're using units. Right now we're talking about units. Now we have seconds, right? Or we have speed. We're looking at speed. We're looking at how fast is the rocket climb for 10 seconds. This would be your location, right? This is your A value. There's your A value. Here's our function, right? There's your equation. You do the exact same thing, except now we're looking at real situations. Should we try one of those? Someone pick a number here to try one of these ones. Have a preference? Let's see, we got an equation. 29 and 30 don't give you equations, do they? Which one? Area of a circle or volume of a sphere? Which one should we do? 29 or 30? They're both pretty good. Let's do 29. Area of a circle. That's a little bit easier. All of you are saying, well, in that case, we should do 30. No. I'm going to leave 30 to you. We'll do 29. Area of a circle. What is the rate of change of the area of a circle with respect to the radius when the radius is 3 inches? In this problem, we need to remember we need to have an equation, and we need to have like a value where we're looking for the slope. The value is 3, right? Our radius is 3. So it's not really x equals 3. In this case, it's going to be r equals 3. And the equation, well, we want to know the equation for the area of a circle. It's the area of a circle. What's the equation of the area of a circle? How do I find the area of a circle, everybody? What's the formula? Something with pi. Someone tell me, what's the area of a circle? Is the formula 2 pi r? No, that's the circumference of a circle. That's the area. That's the part around a circle. Circumference is 2 pi r. What's the area of a circle inside? Nobody knows the area of a circle formula? Come on, you know this. Emmanuel, you know the area of a circle, right? What's our formula? Thank you, pi r squared. Yeah, r radius, exactly. Pi r squared. Area of a circle, pi r squared. Squared because it's area, right? Area is length times width. Oh, sorry, Emmanuel. Length times width, right? That's why it's squared, everybody. Area has 2 dimensions. Oh, interesting. 2 dimensions, area, that's why it's squared. Circumference, 1 dimension, just a length. Length, no squared. Area, squared. 2 dimensions, squared. 1 dimension, no squared. Very interesting. So there's our formula, pi r squared. Our variable is r, so there's our r. So we're going to do pi r squared, and we're going to do it at the value of 3. We're going to use our same formula, our same limit formula to find this, this limit. So let me do that. This is number 29. 29. Find the rate of change of area when a circle is radius of 3. So the area of a circle, we know the formula is pi r squared at r equals 3. So we do the same thing. Limit this time as r approaches 3. Whatever the variable is, doesn't matter. of, use the formula itself, pi r squared minus pi times 3 squared over r minus 3. Same as before. I got pi r squared minus 9 pi over r minus 3. And now I need to do a little manipulation here. I've got this pi everywhere. Well, just like we factored out the -1, I can factor out the pi and get r squared minus 9. Factor out my pi, r minus 3, and you see this r squared minus 9, there we go. There's our thing that we can factor into r plus 3 and r minus 3. And that's why we can now cancel this r minus 3 on r minus 3. So we're going to get pi times r plus 3, oops, on the top. And we're going to get limit, the limit, what's happening here? The limit as r approaches 3 of that equation, which is pi times 3 plus 3, which is 6 pi. And we can leave, usually when we have pi, we just leave it with pi. This is our slope. That's how fast slope changes. That's how fast the area is changing at that point in time. Okay? So you need to know the formula for the area, pi r squared. Use the same limit formula, use that same limit situation where you're finding the limit. Use the equation minus the value over r minus 3 or x minus 3. Your variable this time is just r. Okay? So, a little more clarity how to do these problems, how to find the instantaneous rate of change. Because you're taking the slope, remember you're taking the slope formula, and you're making the slopes match. You're making the x values match. You're shrinking the slope. Instead of being like two separate points, the 2 points are coming together. And when they come together, that's when you find the instantaneous rate of change. That's what's happening here. Your limit, as you're approaching this particular value that you want, of r minus 3 over, of the formula minus the value over, right, your slope formula. All right? All right, I've got one more question for you all. Let's go back to this one right here that we did the graph of. Right, we know the slope, we know the location. Right, here's my line. Right, I know my tangent line. I got my tangent line right here. My question for you is, what's the equation? What is the equation of this line? What is the equation of that line? It is y equals mx plus b. What is the equation? What is the equation of this tangent line? How do I figure out what? I know what the line looks like. I know where it is. Right? I know what this line looks like. I know where it is. I know its tangent right here. I know a lot of information about the line. I should be able to write an equation of this line, right? I should be able to write an equation. What do we know about this line? What information do we know about this line? We know two very important things about this line. And those two things are all that I need to write this equation. Right? I know where it is, I know a lot. what is one of the things I know about this line? Ayala, tell us, what is something that we know about this tangent line? What piece of information do we have? Jesus Ayala, are you in the kitchen too? One piece of information we know about this line. Maybe, Angel, maybe. All right, Angel, you tell me. What is one thing I know about this line? Not sure, Ayala? Your confusion. What's one thing we know about the line? Help him earn his points back, Angel. You tell me. Angel, what is something I know about this line? Two very important things I know. What's one of the things I know about this line? Thank you, Adrian. Yeah, we know the slope of the line, don't we? It's -1. Yeah, that's key. That is m, right? M, we know the slope. Don't worry. I believe you, Angel. I gotcha. All right, Ayala. So we know the slope, yeah? We're good? We know the slope. That's one thing. If I know the slope, I need one more thing about the line to be able to find the equation. If I know the slope, I need to know my y-intercept, right? Yeah, I need to know the y-intercept. The problem is, I don't have the y-intercept. I don't know what it is. But what do I know? Well, I know this is tangent, right? I know this is tangent to a particular location. And so I know what this x and y value of this location are. I have a point. I have a starting point for my graph for this line. And so I know some xy. I know the x is 2. I don't really know what the y is, though. I know it's at 2 because that's where we had our tangent spot, right? That's what we're looking at. We're looking at the y. The x is 2 tangent spot, right? That's the value we had, right? We said I want to find it at x is 2, right? That's where I wanted it at. So I know the x, but I don't know the y. So I know the location, but I don't know the y value of the location. But I have an equation, I have a formula. Look, I have a graph. I know that the point 2 comma something has to touch this graph because we're looking at the slope of this equation. This 1 over x minus 1 equation. Oopsies. What was x plus 1, right? No, x minus 1. This is my equation. This equation can tell me the y value. It can tell me the y value. I know the x value was 2. That's what we're looking for. But what's the y value? Well, I can take this x value, plug it into my equation, and get the y. This is the equation. This graph, this tangent line touches the equation. It's got to find the y value, right? So I can say, okay, 1 minus 2 minus 1. That's going to be 1 over 1. That's going to be 1. That's my y value. Y value going to be 1. So now that I have my point, my 2 and 1, my location, I can use these points to plug into x and y and find my b. So we have all the information we need to find the equation of this line. I found the slope. I found the point. I found the point by taking the x value, plugging it into my equation, getting the y value, right? Finding that y value, using this x and y, plugging in to find the equation. Let's do this. Equation of the line. I know the slope is -1. I know the point is 2, 1. 2, 1. And so my equation is y equals mx plus b. I'm going to plug in all this information. I'm going to say a y value is 1 equals -1 times 2 plus b. I should do these in colors. My slope is -1. My slope is -1. My x value is 2. X value is 2. And my y value that I found by plugging in was a 1. And that's a 1. So I have 1 equals -2 plus b. Add the 2 to both sides. Add the 2 to both sides. Add the 2 to both sides. I get that b is equal to 3. So then my equation is y equals -1x plus 3. That is the equation of this tangent line to the graph. Because I know the slope, I found the slope, and I found the point. My x value is the point. My y value I plugged in to my equation because it's on this graph. It's on the graph. Plug it into the graph. Plug it into my original graph. Find the y value and use that y value in my equation. X and y. Use my slope. Get my line. And this is what you're going to do over the weekend. Find equations of tangent lines. Your assignment is going to be doing the tangent slope equation, doing what we did with, with our formula, right? Our y2 minus our f of x minus f of a over x minus a, right? Our formula with the limit, whether you do the equation minus you plug it in. This gets you the slope, right? Gets you the slope. Once you have the slope, use your x value, plug it into your formula, get the y value, use those x's and y's to find your equation. And I'm going to give you an example of how to do this, an example from the homework assignment, which will be out of the book. So for example, let's do a different question. Find the slope, find the line, find the equation of the line, find the equation of the tangent line. So the steps, let me write down these steps. First, find the slope using the limit as x approaches a of f of x minus f of a over x minus a. So find the slope of the tangent line, that's step 1. Second, find the xy point by plugging the x into the original formula, original equation. That gets you the y, right? Third, using the y equals mx plus b, plug in the slope and x and y to find b and write the equation. So we're using this tangent line, using this slope, using the location of where the tangent line touches the graph, right? Because it's right on that spot. Use that point, use the slope, take the slope and the point, make a y equals mx plus b equation. So you're gonna find some tangent lines, use that same slope formula situation, see what you can figure out. Find the slope of the tangent line, and then use that slope to create an equation, slope and the point. Yeah, third part here says use the y equals mx plus b. You're going to plug in the slope and x and y. Plug in the slope, right, m from number 1, and x and y from number 2 to find b and write the equation. So this tells you your slope. This is your slope m. Whoa. This is your slope m. This is your x here, comes from the a, right? That's your a value. The y you find by plugging in. And plug those in, plug in your slope and your x from the equation that you got, and the y. And find b. Once you find b, you have your equation. Write your equation. Great. The homework assignment is going to be on Schoology. It's going to be out of the book, page, I think, 107. Book, page 107. I don't remember what numbers. I think there's only 7 questions. I think I have 7 questions. Okay. Questions, concerns, worries? So let's run through this one more time. If I wanted to find, for example, let's look at number 9 that we did here. Oh goodness. Let's look at number 9 that we did. If I wanted to find the equation of this tangent line, if I wanted to find the equation of the tangent line at x equals -2 of this equation, what would I do? I did my steps here. I found my slope. My slope was -4. Okay, so we got m. What is my x and y point of this equation? What's the x and y values? I need that x and y point. My x point, it already tells me in the question. I'm looking for the slope here at -2. So my x is -2. What's my y value? How do I find the y value? Where do I take this -2? What do I do with it? I want to find the point where this graph, where this tangent line touches the graph. Which graph? It touches which graph? It touches this graph. Y equals x squared. My tangent line touches this graph. At x is -2. If I know x, I can find the y. plug the negative 2 in here. Negative 2 squared is going to be 4. And that's how I find my x and my y. I take those two and I plug them into y equals mx plus b. Take all these things, plug them into y equals mx plus b, get your equation, and you get your graph. Found our slope, found our point, took this, plugged it in, found our point, use that to make an equation. It's going to take practice, but again, the only way to do this to get better is to practice these problems. So try these 7 questions over the weekend. I will see you all on Monday. I believe we have Monday this coming week. Oh wait, maybe it's not. Maybe it's Tuesday. I think I see you Tuesday, everyone. I think I see you Tuesday. Have a great weekend. Enjoy. I will see you all next time. Bye for now, everybody.